Hi everyone, we're group 4 and we're going to be going over the rational number system. So mathematics is the art of giving the same name to different things. At least that's what mathematician Henry Poincaré said. My name's Alyssa Pierce and today we're going to be going over properties of addition and subtraction as well as properties of multiplication and division. All right, so here we have the properties of addition of rational numbers. So first we're going to start with the closure property, which reads r plus s, which that's rational numbers, and then we have a over b plus c over d, and that's a fraction. So that's the closure property, just pretty much stating the problem. Then we have the commutative property, which is r plus s equals s plus r, or a over b plus c over d equals c over d plus a over b. So if you'll notice, all that means is you're changing the order and your answer is going to give you the same sum. So then we have the associative property, which is r plus s in parentheses plus t. So in the associative property, basically all you're doing is moving the parentheses and it's not going to affect your answer at all. So even the same holds for fractions, which you'll see I have a over b plus c over d in parentheses plus e over f. And then if you just move the parentheses to the two other numbers, it's going to give you the same answer. So the last two are 0 is an additive identity, which is r plus 0 equals r, or a over b plus 0 equals a over b. So basically in layman's terms, that just means anything plus 0 is going to give you that number. It's going to equal itself. So then we have the existence of an additive inverse, which means if you add anything by its negative form, it's going to give you 0. So here as an example, I have r plus a negative r, which is 0. Or a over b plus a negative a over b equals 0. So you might be thinking, what about subtraction? Well, for subtraction, it is neither commutative nor is it associative. And you're asking why? Well, if you switch the order of how a number appears, like 1/2 minus 1/4, and make it 1/4 minus 1/2, those don't equal each other because your answer is different. That's like taking 3 minus 5 and then giving 5 minus 3. The answer is going to be different. And the same for the associative, which means you move the parentheses. So if you took the parentheses from here and put it over the 1, your answer is no longer going to be the same. So now we have properties of multiplication of rational numbers. So we have a few more properties for multiplication. We have the closure property, which you'll be familiar with because I mentioned it in the addition properties, but it's a little bit different. We have r times s is a rational number, or a over b times c over d, and that's a fraction. So basically the thing that has changed is the sign because this is for multiplication. We have the commutative property, which is r times s or s times r. Same holds for fractions, so you're just going to switch the order around in which it's multiplied. For the associative property, you're just going to move the parentheses, much like we did for addition. And the distributive property of multiplication over addition and subtraction. So for this property, you're just going to distribute your number. So here I have r times s plus t. So that means your answer is going to be rs plus rt. You just distributed that r all around the problem. And the same holds for subtraction. So then we have multiplication by 0. So that means anything times 0 is going to give you 0. Then we have 1 is a multiplicative identity, which means 1 times anything is going to give you that anything back. We also have the existence of the multiplicative inverse, which means if r equals a over b and does not equal 0, then there is a unique rational number. So we're going to play a little game here, and if you just want to pause and try to solve these yourself, you can, or you can just follow along with me. On the left, you'll see that I have some properties listed. On the right, I have some examples. So let's see if we can match those together. So we have the commutative property for addition. So if you remember, that's just switching numbers around and you're still going to have the same sum. So that would be this one right there. Then we have the commutative property of multiplication. Same notion, you're just going to take the numbers and switch them around in the order of which it's multiplied. So there we have that. And then we have the associative property of multiplication. So for that one, it's moving the parentheses around. So then we have the multiplication by 0, which means anything times 0 equals 0. Then we have the associative property of addition, which is right there. And then we have 0 is an additive identity, which means 0 plus anything gives you that anything back. So now that we've played that game, I just want to thank you for watching this presentation. Overall, my lesson should have taught you all that Henry Poincaré is right and that math is full of different things with the same name. And as confusing as it can get, it's still pretty easy to understand. So next up, Chelsea is going to give you computations with rational numbers and estimations.
Only a fraction of you will understand the fine line between a numerator and a denominator. My name is Miss Chelsea, and I'm going to be speaking with you a little bit about computations with rational numbers and estimations. Sorry about that. Don't know where I'm going. Sorry, guys. Alrighty, so what we're going to look at first is what does computations with rational numbers really mean? So computations with rational numbers is just different ways that you can use different skills to solve problems using rational numbers. And here I've listed a few of those different skills that you can use. Examples with estimations, mental arithmetic, rounding, and pencil paper computation. Next, we're going to look at estimations. What is an estimate? The definition given in the dictionary says that an estimate is a guess that you make based on the information you have about the size, amount, etc. of something that you have. So what is estimation with rational numbers? It says that many of the estimation and mental math techniques that are used using whole numbers will also work with rational numbers. Estimation plays an important role in judging the reasonableness of computations. So next we're going to look at a few examples of estimations and see if we can get a better understanding here of what that means. So if you look at A, we have 7 over 9 minus 1 over 5. We're going to round each of those fractions to the nearest whole number. So if you look at 7 over 9, you're only 2 away from having 9 over 9, which would equal 1. So you're going to go ahead and round that up to 1. If you look at 1 over 5, that is nowhere near close to being 5 over 5 to round up to 1. So since it's not close to that, we're going to go ahead and round down to 0. So our estimation here would be 1 minus 0 equals 1. Next, we're going to look at part B here, and it says 4 and 5/9 plus 3 and 1/8. So we're going to look at 4 and 5 over 9. That is going to be rounded to 4.5. And then 3 and 1/8 is going to round down to 3 because 1 over 8 doesn't get close to 8 over 8 to make that whole. So next we're going to add those, and you'll have 4.5 plus 3, which is going to equal 7.5. I have one more example here for you, and it says a Cocker Spaniel may grow to weigh about 11.5 kilograms, while the Chihuahua will not weigh more than 2 7/8 kilograms. Estimate how much more the Cocker Spaniel weighs than the Chihuahua. So we're going to pull those numbers out of this word problem, and we're going to look at those numbers and use estimations to try to figure out how much more the Cocker Spaniel will weigh. So we're going to look at 11.5, and 11.5 is right in the middle of the number, so we're not going to round up or round down. We're just going to keep that half the same. And then we're going to look at 2 and 7 over 8. 7 over 8 is almost 8 over 8, which would give us a whole. So we're just going to round that entire mixed number up to 3. Next, we're going to subtract 11.5 minus 3, which would give us 8.5. So this is our answer. The Cocker Spaniel weighs about 8.5 kilograms more than the Chihuahua. Thank you so much for watching, and I hope that this presentation has helped you gain a better understanding on what it means to make computations with rational numbers. Next, Ms. Heather will talk to you a little about the different skills that you can use to solve problems using rational numbers. Thank you.